All right, so 1.3 segments and their measures. So, the first couple of problems basically give you a picture of a segment. And so it's something like they'll have a point on each end of the segment, and basically what they want you to do is take your ruler and measure it. I don't know if it's because my book has stuff on the outside edges, but the answer that they get is not what I get when I measure it with a ruler. So I'm hoping that yours is accurate. But if you're pretty confident in your measuring abilities and your answer's not matching the back, it's probably okay. But just for the sake of us seeing it, I'm gonna, well, maybe if this works. I don't know if these actually have markings on them. Maybe not. We'll just take it away. And I do have rulers. If you don't have one, you can use, but for the moment, I'm just going to show you. They want the answers. It says to the nearest millimeter, but that just means do like centimeters with 1 decimal point. Okay. So on this one is really hard to read. Hold on. There we go. So they want us to take this. I'm hoping that you'll be able to read this more or less. And you need to always look, because the end of a ruler isn't always the 0 starting point. Sometimes 0 is actually in a little bit. But on this particular one, it is. And so it looks like, I know it's hard to read, but I have centimeters here. I'm at 8 and a little bit past that. It looks like I am 3 little tick marks past that. So this one would be 8.3 centimeters that I drew. Now, obviously, if you drew a line on your paper, it's probably not the same length as mine as far as that goes, but that's all that we need to do. I trust that you've all used a ruler before and can measure things. Just make sure you're in centimeters, not inches, when you do it. And I have plenty of rulers if you need to borrow one. It just needs to stay in my classroom afterwards. Okay. Number 20. So these ones say to draw a sketch of 3 collinear points and then write the segment addition postulate for the points. So they give us H is between G and J. So they want us to draw a segment with G and J on the ends and then H between it. So G and J, and then somewhere between, it doesn't have to be halfway, just somewhere in there, we're going to put H between it. And then they want us to write the segment addition postulate for the point. So that says that if we had ABC, if B is between A and C, then AB plus BC is equal to AC. So in our case, I'll put up my book. But in case you ever forget that, this is why you have this lovely book here, so that you would be able to refer to this if it's asking you for that, so that you can see this. Now, again, there's 2 ways we can write this. So either way would be fine. I'm going to do the first one here for our situation. So I've got if H is between G and J, then GH plus HJ is equal to GJ. So you're basically just taking the postulate that you have and changing it for the letters that you're given on these ones. Okay. For problems 23 through 30, they give you a picture of a line, or it's like a segment, that has points on the end, and then it has 3 points in the middle, or well, not in the middle, but at this end. They are P, Q, R, S, and then T is the other end. And so this is going to apply to all of these problems, 23 through 30. They tell us also in the instructions that PT is equal to 20. So that means the distance of the entire segment is 20. QS is 6. And then they tell us that PQ is equal to QR is equal to RS. And then we're going to be finding the different pieces here for 24, 26, 28, and 30. So 24, we're finding RS, 26, we're finding ST, 28, we're finding RT, and 30, we're finding QT. All right, so the first thing that I am trying to find right now is RS. So I know that PT, I know that this whole thing is 20, okay? I know that QS is 6, and what else do I know?
PQ is 3.
How do you know that?
Because Q to S is 6 and Q to R would be half of that, so Q to R is 3.
Okay, yep. So each of these pieces have to be 3 because each of these individual segments are equal to each other. Okay, so that means that this has to be 3, this is 3, and this is 3. So R to S then is 3. What about S to T?
11.
Okay, so that would be, over here we would do 20 minus 9. So we would have 11 there. How about R to T?
6. 14.
14. So we know that this is 11 over here. And we're going R to T, so 11 plus 3. So we'd be at 14. What about Q to T? 17. So we've got the 11 plus 3 and then plus another 3. So you don't necessarily have to have all of this worked out, but I like having the visual to look at for that. What's next? All right, suppose M is between L and N. Use the segment addition postulate to solve for the variable and then find the lengths of LM, MN, and LN. So they tell us that in 32, LM is equal to 7y plus 9. MN is equal to 3y plus 4. And LN is equal to 143. Now, we know for these problems that M is between L and N, so L and N are on the ends, M's in the middle. And I'm obviously drawing my segment like kind of large, but it doesn't really need to be that large, just for a visual to look at. So based on my segment addition postulate, what would the formula be, ignore all of this for the moment, for the segment addition postulate with these letters?
So M plus M, N equals L, N
Yep, LM plus MN is equal to LN. So what I'm going to do is I'm going to take these things that they've told me that these are equal to and plug them into this equation over here, okay, into my postulate. So 7y plus 9 plus 3y plus 4 equals 143. And then you're just solving an equation with an unknown variable. So combine like terms. I have 10y plus 13 equals 143. Subtract 13. So 10y equals 130. Divide by 10, so y equals 13. So I've solved for the variable. That's the first thing that they want me to do. The next thing they want me to do is tell what the length of each of these pieces basically is. So LN, they've already solved for me in this case, so I don't need to rewrite that. Just you can just like circle it that you've looked at it. To do LM, I'm going to have 7 times the number we solved for down here, so 13 plus 9. What's 7 times 13?
65.
Nope.
So 7 times 13 is 91.
Nope. 91 plus 9. So that means that this one is 100. So LM is equal to 100. And then I just need to do MN. So MN is 3 times 13 plus 4. 3 times 13 is
39.
plus 4.
43.
Yep, 43. So that's all the pieces that you had to solve for there with that one. All right, getting into the distance formula now. So they're giving us a graph. Basically, I'm not going to copy the whole thing over exactly, but just to give us a rough where it's at. This point up here, A, is a negative 4, 7. This point over here is B, and it's 6, 2. And then down here, I've got a point at C, which is 3, negative 2. Okay. And they want me to find the distance between each pair of points. So if there's 3 points on here, I should have 3 total answers to this. Okay? So the distance formula, again, just as a refresher, is the square root of x2 minus x1. And we square that plus y2 minus y1. And all that is squared as well. So we're going to basically be finding the distance between A and B, between B and C, and then between A and C. So we're going to have 3 separate answers here. So AB, the distance here, would be the square root of, and it doesn't matter which one you do, I usually just go with this first one. So negative 4 minus 6 squared plus 7 minus 2 squared. So what's negative 4 minus 6?
Negative 10.
And then negative 10 squared is? 100. And then 7 minus 2? 5 squared is? 25. So then this is the square root of 125. Now, if we can break this down, we need to break down our radical. We need a refresher on how to do that. We can make a little factor tree here. What goes into 125?
25 and 5.
25 and 5. 5 can't break down any farther, but 25 can. What does it break into? 5 and 5. So we pull out pairs of 2, so I can pull out a group of 5s, and I have a 5 left. So my answer would be 5 root 5. So that's the distance between A and B. Now I need the distance between B and C. So this is going to be the square root of 6 minus 3 squared plus 2 minus a negative, so that becomes positive. So 2 plus 2 squared. 6 minus 3 is 3 squared is
9.
plus 2 plus 2 is
4.
squared is 16, and that gives me the square root of 25, which is
5.
5. So the distance from B to C is 5. And then we've got one more. We've got to do A to C. So this is going to be the square root of -4 minus 3 squared plus 7 minus a -2, so that's going to be plus, so 7 plus 2 squared. So -4 minus 3,
No, -7.
-7 squared is
49.
49. And then 7 plus 2 squared. So if we got 49 plus 81, which is
130.
square root of 130. I'm going to see if I can break this down. So 130 breaks into what?
2 and 65.
And 65 breaks into 13 and 5. Now none of that can break down any farther, and I don't have any number that's used twice, so this is as simple as it can be. So we would just leave that like that. Questions on this one or anything so far? So this is distance between pairs of points. The next one is basically they give you a graph again, but they've made them into segments. So they've got stuff like segmented off, and they want you to find the length of the segment. So it's doing the exact same thing, but with the segments. So 38, we have, again, I'm just going to kind of roughly draw it for you. Basically everything is in quadrant 1 here. We have, and 4. So over here I've got G, which is the 0.51. Directly above it is the point F, which is 5.6. Over here I have E, and that is the 0.14. And then in quadrant 4, I have H, which is the 0.4 -4. And then they're connected. H is connected to G, G is connected to F, and E is connected to G. So they want us to find the length of each segment. So obviously there's 4 points, so that would be a lot of distances to find otherwise. But they're telling us that we just are finding it for each segment. So which segment do y'all want to start with?
E and
e to g. So EG is going to be the square root of, I'm going to have y'all tell me this time. Since I did the last ones.
5 minus 1 squared and 1 minus 4 squared.
Yep. So 5 minus 1 squared plus 1 minus 4 squared. 5 minus 1 is 4 squared is
16.
plus 1 minus 4.
3. Or negative 3.
Negative 3 squared is
9.
9. And then that would be what?
25.
Square root of 25 is,
5.
yep. So that's one segment taken care of. What segment do you want to do next? GH. How would I write this one?
Four minus 5 squared. Negative 4 minus 1 squared.
Yep. So then I've got 4 minus 5 is,
Negative 1.
squared is,
Positive 1.
yep, positive 1, plus negative 4 minus 1 is,
Negative 5.
negative 5 squared is
25.
25. So that gives me the square root of 26. Can that be broken down at all?
13
Will I be able to go any farther with it?
No.
So if you know you can't go any farther with it, you don't need to worry with it. I just mainly was doing them up here so we could see how to break them down, just to check. But if you know it's something like that where it can't go any farther, you can feel free to just stop. So there's GH. So the last one we need to do is FG. So somebody tell me what to put for this one.
You said F. 5 minus 5 squared.
Yep.
1 minus 6 squared.
Yep. So what happens to this first piece right here? Huh?
Cancels out.
Yep, it all cancels, so that's just 0. So then I have 1 minus 6
Negatives 5.
squared
25.
and square root
5.
5. So that would be how you find those. Making sure. Yeah, that's all they ask you for with these ones. The next problems are going to be similar, but they're just giving you the points. They're not giving you a picture, which, I mean, the picture's nice, but you don't really need the picture. And they're asking you to decide if PQ congruent, see if it's congruent to QR. So we're going to see if the two segments are congruent. Okay, so basically they're going to give us a point for P, for Q, and for R, and then we're going to need to find the distance between P and Q and R. If they are the same, then they're congruent. If they're not the same, then they're not congruent. So, 40. P is 4, negative 4. Q is 1, negative 6. And R is negative 1, negative 3. So somebody tell me how to find the distance from P to Q.
Which one can you do again?
Let's see if somebody else can do it.
It's 1 minus 4 squared plus negative 6 minus 4 squared.
Plus 4 minus negative. So 1 minus 4
Negative 3.
squared
9.
9.
plus negative 6 plus 4
-2.
squared. So this is the square root of 13. Can that break down any farther? Nope, so I can leave it. Then I need to do QR. Somebody different, do Q to R for me. If you don't volunteer, I'm going to start calling on people.
-1 - 1 squared, and then plus -3 plus 6 squared.
Yep. And then -1 minus 1 is -2 squared is. And then over here, -3 plus 6 squared. So this is also the square root of 13. So because these are both the square root of 13, then we can say that PQ is congruent to QR. All right, we've done a lot of distance formula together. I want you to try the next one on your own and see how we do. Same instructions as number 40. We're finding is segment PQ congruent to QR. Point P is 5, 1. Point Q is -5, -7. And point R is -3, 6. So take a minute and try this one. I'll leave the previous one up here for reference for you.
Stacy, do we have like a nurse or something?
Huh?
Like a nurse or something?
I mean, Miss Hughes, why? I mean, she's not a nurse, but
Headache.
she's not gonna be able to give you anything.
We don't have a nurse at the school.
I mean, not technically, but even if we did, they can't give you medicine. Unless you have medicine that your parents dropped off in the office for you. But we're almost done. If you want to go see her after I give you the homework problems, you can do that.
It's alright, it's almost the end of the day.
All right, what do we think? Are they congruent or not congruent?
No.
What did we get for PQ?
Square root of 164.
Yep, and what about QR?
Square root of 173.
Yep. Technically speaking, I think PQ could have been broken down, but since we're just seeing if they're congruent, it's not that big of a deal. It's just if we're like leaving that as like our answer. So they are not congruent. I forgot to write down what problems I want to do. Okay. Problems. They're due Friday. Problems are 13, 19, 23, 27, 31, 35, 39, and 43. But you have time now to work on them. We haven't been having a ton of time, but we do have time today for you to work on them. But if you don't finish, you don't have to have them due for tomorrow, but they are due Friday at the beginning of class.
Can I get water?
And we are doing the next section tomorrow.